problem 5-27, and this one is about perpetuity. So what we have is, assuming today's date is January 1 of 19, and we have the opportunity to make an investment that's going to pay us $130 every year starting next year, and that's going to continue forever. So the whole forever language means that really this is what kind of constitutes a perpetuity, and we have a discount rate of 8%. So the present value of a perpetuity is pretty easy to calculate because all we need to do is just take the cash flow, which in this case is the 130, and divide it by our discount rate, which is 0.08. So the present value in this case is $1,625. So the best way to think about this and to understand why this makes sense is to kind of think of it in the reverse. So if we were to invest $1,625 right now and we were to earn an 8% rate on that basically forever, then that would kick off to us 1625 times 0.08. So each year we would get $130. And the only way that that could ever happen in perpetuity or forever is if the principal balance remained the same. So we would earn the interest on the investment forever, and again, the principal would not be touched. And that's the only way that we could get our 8%, our $130 every single year forever. Okay, so for part B, we are assuming that the first cash flow comes immediately, and then we get subsequent cash payments every January 1 thereafter. So how much would we pay in this scenario? So what this is saying is that we would have our present value, our 1625, plus we would get a payment immediately. So we would get an extra $130. Okay, so really what our present value or amount that we'd be willing to pay for that investment would be $1,755. Again, think about this kind of in the reverse, in that we would have a $130 payment up front, and then the perpetuity, the $130, would start the following year and go on forever. So the only way to pull that off is if we have $1,755 that we would be willing to pay for it up front, because that's going to give us the 130 right off the top, and then the rest would stay as a principal balance forever, 1625, which would then kick off the 130, the 8% return from there on forward. And then part C says, suppose the investment's first cash flow is 3 years from now. So in this case, instead of receiving the first cash flow the end of next year, or 1 year from now, I should say, we're going to receive it in 3 years. So what that means to us is that's a 2-year delay. So again, instead of receiving the cash flow in 1 year, we're going to receive the first cash flow in 3 years. So that is a delay really of 2 years of that first cash flow, or that essentially that present value. So with this, what we can do is calculate a present value, which we would use again the same discount rate of 8%, and number of periods we're going to put in 2, because we want to figure out what we would be willing to pay for this 2-year delay. So what the present value would be to us, and our future value would be what we had already calculated of 1625, because that is the present value if this was to start receiving the payments 1 year from now as opposed to 3 years. So what we're doing is we're discounting the value that we calculated in part A by 2 years, because we would be willing to pay less than $1,625 if our cash flow payments, our $130, are going to be delayed by 2 years. So in this case, the present value of this scenario where we have a 2-year delay is really $1393.18. That's how much we would be willing, or how much the investment would be worth.